Welcome back to this video lecture series on data structure and algorithms. Today, our lesson is Introduction to Stack Data Structure. So let's start. So what is stack? Well, stack is a linear data structure which follows a particular order in which the operations on stack in terms of addition and removal of elements are performed on it. These operations always take place at a same end. This is the same end here. So here, this term a particular order and written in between the brackets LIFO. This LIFO stands for last in first out. So this data structure follows this rule of last in first out, that is the data which will be entered last onto the stack will be removed out at the first. Now, after knowing what stack data structure is, let us look at some of the terms and operations we use on this stack. So first comes the top keyword. Well, the single end of the stack from which all the operations get carried out on the stack is called the top of the stack. Whenever we want to implement any kind of operation, say addition, removal, or anything, we have to have the access of this top, because this is the single end of this data structure from where we can do everything with this stack. So here in this diagram you can see that this is pointed as the top of the data structure. So the data which remains at this top is added into the stack last, and if a removal is required, then this data at the top will be removed first. Then comes push. Well, this push operation or this push function is implemented on stack to add an element onto the stack. Next is pop operation. Pop operation is just the reverse of push, that is, this function is implemented when we want to remove an element from the stack. There's a function called isEmpty, which we often use to check whether the stack is empty or not. Now, when this point comes to check the emptiness or fulliness of stack, we have to consider two terms here. Well, stack is said to be in overflow state when it is completely full, and it is said to be in underflow state if it is completely empty. So there's a thing that stack is an abstract data type which has predefined boundary or capacity. So as we have already know the size of the stack previously, so we can count the number of slots in the stack and see whether it is full or not. If it is full, then we say that the stack is in overflow state, and if we see that the count of the slots in the stack is 0, then we can say the stack is empty and therefore it is in underflow state. Lastly, we'll get to know of some of the applications of stack. The very first and important application of the stack is balancing of symbols or parentheses. So whenever we write any kind of functions, often we use a pair of parentheses and a number of parentheses. So we can use this stack data structure to have a check whether these parentheses are used by being balanced or not. And if they are not balanced, then the program will throw an error. Next comes, we can do conversions like infix expression to postfix expression. Well, infix expression is an expression where the operators remain in between the operands, like x plus y. And postfix expression refers to an expression where the operators appear after the operands, like x, y plus. Some of the other applications of stacks are redo and undo features in many editors, Photoshops, then forward and backward feature in web browsers. And lastly, when it comes to this algorithm and data structure part, we can use the stack data structure to implement many algorithms like Tower of Hanoi, stock span problem, histogram problem, etc. So this was the introduction and application of stack. Thank you for watching this video and staying with us. See you next time.